Today we are going to discuss the solution of ENDSEM examination of Introduction to Data Science. Question 1, first part is take a real world program and explain how each CRISP-DM phase would be applied to address this problem. Include at least one specific application area for each phase. The problem statement is in a subscription based SaaS company, customer churn has reached 8% monthly, costing approximately 500 lakh dollars in lost revenue. The business goal is to reduce churn by 15% within 6 months by identifying at risk customers and triggering targeted retention campaigns. The phases of CRISP DM are first is business understanding. Define the business objective clearly. Introduce monthly churn of 8 to 6.8% within 6 months. Identify successes metrics. Determine how predictions will be operationalized. Retention team will contact high risk customers with personalized offer. Understand constraints. Campaigns must be cost effective, targeting only high probability churns to maximize. The application area would be business strategies, customer retention, economics, marketing, budget allocation. Second, data understanding. Gather historical customer data spanning 24 months, including demographics, that is, age, location, company size, industry. Second, usage metrics, monthly active days, feature usage, frequency, storage consumption. Third, support interactions, number of tickets, resolution time, satisfaction scores. Fourth, financial data, monthly revenue, payment history, contract terms, behavioral signs. Fifth, customer inactive for 30 plus days have 80% churn probability. Contract downgrades precede churn by 2 to 3 weeks. Missing payments record of 5% of data set indicate data quality issues. Application area would be data analytics dashboards, customer health scoring systems, and data quality monitoring. Third is data preparation. Transfer raw data into machine learning ready format, that is, handle missing values or normalize numerical features using Z score scaling to mean 0 and standard deviation equals 1. Encode categorical variables, one hot encoding location, industries. Fourth, feature engineering. Create aggregated features like days since last activity, average support tickets per month, contract downgrade flag. Fifth, feature selection. Last, create train validation test split 60% of train, 20% of validation, 20% of test. Application areas would be data engineering pipelines, feature stores, automated data pre-processing system. Fourth is modeling. Train and compare multiple algorithms. First, logistic regression. Fast, interpretable baseline achieves 76% AUC. Third, decision tree captures non-linear relationships. Third, random forest. Ensemble approach reduce overfitting 88% AUC with stable predictions. Fourth, gradient boosting. Sequential boosting highest accuracy. Hyperparameter turning using grid search on validation set. Random forest selected as best balance of accuracy and interpretability. Application areas would be machine learning model development, algorithm evaluation frameworks, hyperparameter optimization. Fifth is evaluation. Accesses model performance on holdout set using business relevant matrices. That is, recall 85%, precision 72%, F1 score 0.78, AUC that is 0.88. Conduct pilot with small customer segments. Provide retention offers to top 200 highest risk predictions. Pilot results have 40% churn reduction in treatment group versus 8% in control group. Validation business value. Application areas would be model validation, A/B testing infrastructure, business impact assessment. Sixth is deployment. Integrate model into production environment. First, deploy trained random forest model to prediction server. Second, trigger retention actions automatically. Fourth, routes high-risk customers to retention team via CRM system. Fourth, logs all predictions with time spent for monitoring. Implement continuous monitoring, track model performance monthly to detect performance degradation due to data drift. Set up retraining pipeline to train model quarterly with new customer data. Application areas would be real-time decisioning systems, CRM integration, customer communication automation, production monitoring dashboards. B part of question 1 is differentiate between structured, unstructured, quantitative, and categorical data with suitable real world examples. First, structured data. Data organized in rigid, predefined schema with defined data types stored in rows and columns are known as structured data. They follows a specific format with clear relationships. They are fixed format, curable, easy to analyze, and uniform structure. Example, banking customer database with columns customer ID, name, account balance, opening date, data fixed perfectly into SQL relation databases. Tools, SQL, Excel, relational databases. Second, unstructured data. Data without predefined structure or format. It comes in various forms and cannot be easily stored in traditional databases, that is, rows and columns. Categories would be variable format, difficult to query directly, requires pre-processing, and diverse types. Example, customer review text. This product is amazing. Shipping was fast. Product images, customer service call records. Tools for analysis, ANP tools, computer vision, no SQL databases. Fourth, quantitative data. Numerical data representing measurable quantities supports arithmetic operations and statistical analysis. Characters. Numerical values can be discrete or continuous, supports mathematical operations. Example, discrete. Number of customer complaints, website page views. Second, contiguous, customer age, temperature, monthly spendings. Analysis, mean, standard deviation, correlation, regression modeling. Fourth is categorical data. Definition is non-numerical data representing categories, groups, or label. It is used to classify observations into distinct groups. Characteristics are discrete groups, no natural ordering, requires encoding for modeling. Example, ordinal education level, that is high school, bachelor's, master's, PhD. Customer satisfaction, that is poor, fair, good, excellent. Nominal, that is unordered, gender, male, female, other, product category, and payment method. Encoding methods are one hot encoding, ordinal encoding, and labeling encoding. Thank you.